Well, hello there. Welcome to the 8th grade math lesson for Monday, August 31st. This lesson is going to be taped, so it won't be live, obviously. So if you need to talk to your teacher, they will be available during 7th period. So you might be able to get on then. But Mondays is just a taped lesson. We call that asynchronous. So let's look at the agenda for today. The agenda for today is good things, learning target, and lessons on adding and subtracting fractions. So that's what we're going to be doing today. So let's go ahead and get started. So what are your good things? Obviously, you can say it into the computer, but since this is a recording, we won't be able to hear you. So what I'll do is, this is Mr. Roden, and I'll be making the lesson today for Miss Horner and Mr. Sansoni and myself. And I would like to just share my good thing. My good thing is I got outside this weekend and went fishing, and I love to go fishing. So in any weekend that I get to go fishing is a good weekend. And I also got to spend some really good time with my family. My two daughters and my wife. So it was a great weekend, and that's my good thing. Hope you have some good things. Maybe you can share with your teacher tomorrow during your live lesson. Awesome. So let's go ahead and get started on the lesson for today. So if you don't mind, I'm just going to toggle through here. So excuse my toggling if it's slow. All right. So today, guys, our learning target is going to be, let me pull this over here and so you can see this a little better. I will be able to add and subtract fractions. I understand that a lot of us sometimes struggle with fractions, and I get that. Fractions can be sometimes a little bit confusing, but they shouldn't be. And adding and subtracting fractions seem to be the area that when we need our kids to do a math problem and it involves some sort of adding and subtracting fractions, they automatically just kind of freak out on us. So we don't want you to freak out. We want you to just look at fractions as, yeah, we can do that. They're no big deal. So let's take a look at fractions, shall we? So I'm going to come down here for a second, and I want you to look at these two pictures. Look at these two pictures, okay? All right. So here's two pictures. And what you can think of this as a pie or a pizza or whatever. And first of all, I can see that I've labeled them wrong. This is not 1/3. This is 1/4, Mr. Roden. Come on, Mr. Roden. I preset this last night. So we can see that this is 1/4 because 1 out of 4 of the spaces are filled in. And we're assuming that each one of these circles is the same size and each part of these spaces within the circle are equal. And so what is this fraction right here? Well, yeah, that's just 1/3. So we have 1/4 of a pizza or a pie, we'll call it pizza, that let's say has been eaten. And over here we have 1/3 of a pizza that's been eaten. Well, first, an interesting question would be, well, which one's greater? Which one's larger? Which one is a bigger piece of pizza? If these circles are the same size, which piece is bigger? Is the 1/4 orange piece bigger or the 1/3 blue piece bigger? Well, yeah, obviously the 1/3 is bigger. Now, let's say I wanted to say, well, let's say I ate this much of this is maybe a pepperoni pizza and this is a cheese. Well, how much pizza total did I eat if I ate one piece of pepperoni and one piece of cheese? Let me just kind of write that in there. Let's say this is pepperoni, P for pepperoni, and C for cheese. So if I wanted to know how much pizza total did I eat as a fraction, if I add them together, well, what would I do? Well, that can be confusing sometimes. Would I just add straight across? Would I say 1 + 1 is 2 and 4 + 3 is 7? Did I eat 2/7 of a piece of pizza? Well, no, that doesn't make any sense at all. What we need to do is break them up into even parts. Well, if we look at 4 and we look at 3, if we look at the multiples of 4, we have 4 times 1, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and so on. I think that's enough right now. And then we have 3 times 1 is 3. We have 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15, dot, 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 dot. Do you see a common multiple that they have, this least common multiple that both of these have in common? This is 12, sorry. I don't know why I put a 4 there. It's 12. Well, yeah, it's this 12 right here that I should have written. It's 12. So what we could do is we could break each one of these into twelfths. Okay, so instead of having 1/4, we're going to break it into twelfths. Well, how would we do that? Well, if you multiply 1/4 by 3 on top and bottom, and it won't change the value of the fraction as long as you're multiplying it by the same number on top and bottom. Well, 3 times 1 is 3, and 4 times 3 is 12. So we could break this little piece into 3/12, just like that. 1, 2, 3. And you could do that for each one of these. 1, 2, 3, 1, 2, 3, 1, 2, 3. And what that's going to give me is 12 twelfths. It's still the entire pizza. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But 3/12 is equal to 1/4. And the reason we're doing that is we can compare these two. Now, if I'm going to multiply 1/3, then I've got to multiply that by 4/4, because 3 times 4 is 12. And so 4 times 1 is 4, and 4 times 3 is 12. So now we can break this into 4 pieces. So let's see if I can do this. Is that 4? 1, 2, 3, 4. So we can break this into 4. And we could do the same thing over here. 1, 2, 3, 4. Sorry for it's not very neat and it looks kind of messy, but hopefully you get the point. 1, 2, 3, 4. So right here, what we have, if you add them all up, you have 12 twelfths here. Okay? So 1, 2, 3, 4. Now we have equal pieces that we can talk about. So this piece right here is going to have 3/12 filled in. And this piece right here is going to have 4/12 filled in. See that? Now you can add them up. And so you get, well, what's 3 plus 4? Well, 3 plus 4 is 7. And then you just keep the common denominator because that's the equal piece that we added up. See that? So it's 7 out of 12. So let's make sure we have it. So 1, 2, 3, 4, 5, 6, 7. We ate 7/12. And we always want to make sure we simplify. Is there a number that will divide 7 and 12 besides 1? Well, no. So this is our final answer. So we ate 7/12 of a pizza. Okay, we can see that. Now, what we can also do is we can figure out, well, let me scroll down here for a second. See if I have a little bit more room. Hold on. Let me go up here a little bit. Got this little, let me see if I'm going to use this little fancy tool I'm learning on OneNote here. I think I make myself more room. Look, this is going to be cool, guys. Whoa, I just made myself more room. That's awesome. Man, I'm getting to be a pro at this OneNote stuff. Okay, what if we want to subtract? Well, subtraction is the same thing. The only thing is if we don't want a negative number, we're going to have to start with the bigger one first. Well, which one was bigger, the 1/3 or the 1/4? Well, yeah, the 1/3 was bigger. And remember, when we have common denominators, we want to use the common denominator, not the original fraction, but the common denominator. So we just go 4/12 minus 3/12. You subtract, and we know that we get 1/12 because 4 minus 3 is 1, and we just keep the common denominator. So why is everyone so scared of these fractions? They're really easy. Okay, so what I want to do now is I don't want to have to do the picture. I just want to do problems where I get common denominators, and I'm going to have you go ahead and do those right now. So we're going to do we'll do these together, and then I'm going to give you some problems, okay? So let's go ahead and do example number 1 together. So make sure you're writing this down. So if you don't have a piece of paper or something to write on, I need you to write this down because this is your first example. So pause the video right now and go get a piece of paper, a pencil, maybe get a drink, get a snack, get your, do some yoga or something, but be ready to do this example, okay? All right, so after pausing the video and getting all ready, let's go ahead and do this. So I don't want to have to draw the pictures of the pizza and everything because it's almost lunch and that makes me hungry and I don't want to think about pizza because then I'll want to go eat. So right now I'm just going to do it without having to draw the pizzas, okay? So example number 1. Well, let's see here. So I need a common denominator. 5 and 4 are not common denominators. Some of you can already start to see this in your head. And if you can, congratulations, you're doing great. If you can't see it in your head, just take the 2 denominators, so 5 and 4, and just start listing them out. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. 5 times 5 is 25. Okay? And then you could do 4 times 1. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. And then you could go 4 times 6 if you wanted to go 24. But what's the common denominator or the least common denominator? Well, yeah, it's this 20 right here. See that? It's the 20. So what we want to do is we want to make these fractions into 20ths. Okay, so let's go ahead and do that. So if I have 3/5, what do I need to multiply 5 by, this denominator, to make it into a 20? Well, yeah, I'd need to multiply it by a 4. Now, if you multiply the bottom by a 4, in order to keep the fraction equivalent, you have to multiply it by a 4 on top. Because really, 4 over 4, this whole piece right here, that's just 1. Anything over itself is just 1, and multiplying by 1 does not change the value of the fraction. It's not magic. It's not voodoo or anything. It's just a simple multiplication by 1 that allows us to get into the denominator that we want. So let's multiply straight across. 3 times 4, well, 3 times 4, let me change it back to green here, is 3 times 4 is 12. And then 5 times 4 is 20. So we now have written this 3/5. We've converted into an equivalent fraction of 12/20. Now, what would we multiply this 4 by right here to get it into 20? So I want you to think about that for a second. Well, yeah, I think you just got it. I think you would multiply that by 5. Let me change that to purple. That's the multiplier. And then remember, we want to multiply by a value of 1, so we got to put it over another 5, because 5 over 5, let's make sure that everyone gets that, that's just 1. And multiplication by 1 does not change the value of the fraction. So just multiply straight across. So here we go. 4 times 5, what is 4 times 5? That's 20. 1 times 5, that's 5. Okay, awesome. So now you're ready to add them. Remember, when we add them, we don't add the denominators. We just copy those, the common pieces. So that's 20 right there. And then 12 plus 5. Well, 12 plus 5, I believe, is 17. And so now we get 17 over 20, and I believe that is reduced. So that's a perfectly fine fraction. All right, let's keep going here. Let me arrow down here a little bit. Let's see. Oh, example 2. Oh, I haven't made example 2 yet. So let's go ahead and do example 2. So let's say I have 1/2, and I want to add to that. I want to add to that 7/8. Okay. Now, some of you may have said, Mr. Roden, I am noticing something. In order to find a common denominator, let me go up here really quick. On this problem, all you did was, on the very first one, all you did was you just multiplied 4 times 3 and got the common denominator of 12. And on this one right here, Mr. Roden, let me go down here. You multiplied 4 times 5 and got 20. So Mr. Roden, I think my theory is you don't have to do this long list. You can just multiply the two denominators together, and that will always give you their common denominator. Well, that's true, but it won't always give you the least common denominator. What do you mean by that? Well, if I multiply 2 times 8, I get 16. But will that be the least common denominator? Well, let's check that really quick. So if we take 2 and we take 8, and we list out the multiples. So 2 times 1 is 2. 2 times 2 is 4. 2, 4, 6, 8, 10, 12, 14, 16, 18, right? And then we can keep going dot, dot, dot. Now, let's do this. Let's list the multiples of 8 out. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. And dot, 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 dot. Well, if you notice, I'm going to do a highlighter here. Yes, 16 is common to both lists, but is there a smaller number, a lesser number? Because we always want to keep it this least. But if you look, there actually is, let me green here, this 8 and this 8. So we don't want to always just multiply them together, because when we do that, we may not get the least common multiple. In this case, we have a multiple that is actually smaller than just multiplying together. So 8 would be our least common denominator or our least common multiple. You can say it either way. Okay, so what are we going to do to convert this 1/2 into a common denominator of 8? Well, yeah, we're just going to multiply it by 4, and we're going to multiply this by 4, and then what are we going to multiply this guy? Well, 8 times 1, and you actually really want to just write the 1 there, just so you know that there's no magical things happening here. You're just being very, everything's just logical, and it works out just the way it should. Okay, so now let's switch it back to green here, and then let's multiply it through. 1 times 4 is 4. 2 times 4 is 8, so you get 4/8. Plus, 1 times 7 is 7, and 1 times 8 is 8, so you get 7/8. Again, didn't change anything because you just multiply by 1. Now we just do our adding it up. Well, keep the common denominator, which is 8, and then just add what's 7 plus 4. Well, 7 plus 4 is 11. Okay? Now, this is an improper fraction, but this is perfectly fine. I know some of you may change this into what? 1 3/8. Because 8 goes into 11 one time with a leftover of 3. This is okay. But you know what? We actually prefer improper fractions as long as they're reduced. We think that improper fractions are the best answer in 8th grade, because we can do a lot more math with improper fractions than we can with mixed numbers. Okay, so we actually prefer improper fractions to mixed numbers, and that's kind of weird because sometimes teachers in the past have not felt like that. All right, let's do one more example together, and then I'm going to give you some to work on here, okay? All right, so let's do one that is a mixed number, okay? So let's say, oh, sorry guys. What happened? Oh, okay. So let's say for a second that I have 1 4/7, and I want to add to that 2 3/14. Okay. Now there's a couple things you could do. You could add the whole numbers and then just worry about the fractions and put them all together in the end. One thing I kind of prefer to do is sometimes I don't, like I said in that last one, we don't prefer improper fractions. We prefer improper fractions, not mixed numbers. So why don't we just get rid of these mixed numbers? And how do you do that? Well, it's really, really simple. You just take whole number times denominator, add numerator. Okay, let me see that again. Whole number times denominator, add numerator. And this is example number 2. If you're following along with the example. So 1 times 7 is 7, plus 4 more is 11. So this is 11/7, plus 2 times 14. What's 2 times 14? Was that 28? Let's see, 14 times 2. I think that's 28, right? 2 times 4 is 8. 28, right? Okay, so this is going to be 28 plus 3 more. So 28, 29, 30, 31. So this is going to be 31 fourteenths. Now, these seem really, really ugly and scary, but what's the common denominator here between 7 and 14? Again, we don't want to multiply 7 and 14 together. That would give us a very big number. It's actually just 14, because if you list out the multiples of 7 and you list out the multiples of 14, the smallest number they're going to have in common is 14. Okay, I could keep going, but I don't want to because 14 is their least common multiple. All right, so let's do that. So what do we have to do to this fraction right here? Well, we need to multiply it by 2. Multiply it by 2. Okay, so that gives me 22. Oh, I should probably put that in green. Erase that. Just be consistent here. So that's going to give me 22, because 2 times 11 is 22, over 14, right? Plus, this is going to give me, oh, I don't have to do anything here. It's just multiply by 1, maybe. Do my little multiplying color. Times 1, right? So let's see here. That's just 31 over 14. See that? And now we just add the numerators. The numerators being the top of our fraction. Copy the denominator, which is 14, and we add. Well, some of you can do that in your head. Some of you can't. If you just want to do a little side problem, 22 plus 31. Well, 2 plus 1 is 3. And so what do we get? 53 over 14. 53 over 14. I believe 53 over 14 is reduced. I don't think there's another number that will go into that. I don't believe so. I think we're done. So 53 over 14. And remember, impropers are okay. Okay, improper fractions. Okay, so I'm going to give you a couple to do on your own here. Let's see if I haven't made them up yet. And now your job is to do problems on your own, and we'll come back to them. So I'm going to title these On Your Own. So on your own. Okay? And I'm going to give you, let's say, we'll just keep going with example number 3 is going to be on your own, and example number 4 is on your own. So once you have these copied down, I want you to go ahead and pause the video and see if you can get them by yourself. All right, so let's do the first one. Let's go 6 2/3 plus 3 4/5. I want you to try that one. And let me arrow down here a little bit, give myself some room here. Example number 4. I want you to do, let's do a subtraction problem. How's that sound? Let's do 8 5/6 minus 5 1/2. Okay? So again, I want you to pause the video and work these problems out and see if you get the answer that I get. Okay? So time to pause. All right. So let's go ahead and work these problems and see how you did. All right. Well, there's multiple ways, and if you had a teacher teach you a little different way, that's fine. Okay, I'm not saying I'm I'm not the grand authority of fractions, but what I am, let me see if I can. What I am, ladies and gentlemen, is I am the I don't know what I'm doing here. I am a math teacher, so this is just the way I've taught a lot of kids, and hopefully this helps you. If you have another way and you can still get the same answer, do it that way. Don't just do it my way. Okay, so here we go. So first thing what I'm going to do on number 3 is I'm going to convert it to a improper fraction because I don't want to deal with mixed numbers. Okay, so here we go. So it's 6 times 3, whole number times denominator is 18, 19, 20. So this is going to give me 20 over 3 when I convert it to an improper fraction. Plus, let's see here, 3 times 5 is 15, and 15 plus 4 is 19. So that's 19 over 5. Okay, now we need the common denominator here. So again, you can list it out. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. And then you could do 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20. And we can see that our common denominator is, different color here, blue. Our common denominator here, guys, is the 15. Now, some of you can do this in your head, and you're like, Mr. Roden, why are you showing this off to the side? That's easy. Well, some kids can get it, some can't. So I'm just trying to explain it as clear as I possibly can. All right, so here's the deal. On this fraction right here, we're going to need to multiply by, well, let's see here, 3 times 1, 2, 3, 4, 5, right? So I need to multiply this guy by 5. And then what do I need to multiply this guy by? 1, 2, 3, right? So I need to multiply this guy by 3. Okay, here we go. Let's do this math here. So let me go to green here. I'm trying to make extra space with this little ticky-tock bar here. Let me see if I can do that. Make some extra space here. Let's see. Look at that. Yeah, we need to make some extra space. I like that. Okay, so with that being said, let me erase these little things here because they're kind of bugging me. All right, cool. All right, so now let's see here. Okay, so 20 times 5. Let's see here. I'm just going to do that off to the side. I think I can do that in my head, but just to show you. 20 times 5, let's see here. That's a 0, that's a 10. So 20 times 5 is 100. So this is going to give me 100 over 15, right? Plus 19 times 3. I don't know that one in my head, so I'll multiply that out. 9 times 3 is 27. Hopefully you remember those facts. 3, 4, 5. So that's 57 over 15. Does this look like something you got? Hopefully I didn't make a mistake. Sometimes I make a mistake, and you guys can tell me, but I think I'm right here. Okay, here we go. So 100 plus 57 is 157 over 15. Now, I want to make sure I can't reduce this. Let's see here. The only number I would probably think that could go into both of these is 3. And so here's a quick rule of 3. If you add the sum of the digits, and the sum of the digits is divisible by 3, then the entire number is divisible by 3. Well, I know 15 is divisible by 3, so the question is 157 divisible by 3? Well, let's see here. 1 plus 5 is 6, and 6 plus 7 is 13. So when you add those up, you get 13 here, and 3 does not go into 13. So 3 does not go into 157 and 15. So I think this is reduced. 157 over 15, and I think you're done. Okay, so I think that is a absolutely fine answer you have there. Okay, sound good? All right, now, last problem. I'm going to pause this for 1 second here. Sorry. Getting distracted here. Pause, Mr. Roden, pause. Going to pause. All right, sorry for that craziness there. I had to pause, but now I'm back. Okay, let's see how you did on this last one before we set you free on your work for today. All right. Let's do this. So we have 8 and 5/6 and 5 and 1/2, and we want to subtract this time. Okay, so remember our operation. We always want to keep an eye. We want to keep an eye on that operation. We're actually subtracting, so don't add. Okay, so again, let's go ahead and do it. Let's see if we can do it without making the list here. So 8 and 5/6. So let's first of all. You should have converted this to an improper fraction. That's what I would do. So 6 times 8 is 48. And we get 48. And then we want to add 5 to that. So that's going to give us, what? Is that 53? Am I right there? 48 plus 5 is 53. So this is going to give me 53 over 6 minus 5 times 2 is 10 minus 11. So this is going to be me 11 over 2. Okay. All right. Next thing we need to do is we need to go ahead and get a common denominator. What's the common denominator between 6 and 2? Well, yeah, the common denominator between 6 and 2 is 6, the least common denominator. It's not 12, it's 6, because 6 is the least common denominator. So we're going to multiply this by 1, because we don't have to change it, and we're going to multiply this by 3 over 3, okay? And then we just multiply straight across. Well, 53 times 1 is 53 over 6, because 1 times 6 is 6, minus 33 over 6. Now remember, we're subtracting here, okay? So you're going to put a 6 here, and then you're just going to take 53, and you're going to subtract 33. And so we have 50, let's see here, 3 minus 3 is 0, and 5 minus 3 is 2. So we get 20 over 6. Now, here's the thing, and this is good stuff right here. So what we can do now is we can reduce, right? We can reduce. Well, what number goes into 20 and 6? Well, yeah, what goes into 20 and 6? 2 goes into 20 and 6. 2 goes into 20 10 times. 2 goes into 6 3 times. So what we have now is 10 over 3. And so that's an improper fraction. Again, we like improper fractions. We could convert that to a mixed number. That's pretty easy. 3 goes into 10 3 times with 1/3 left over. So either one of these are fine. Okay, so what I want you to do is your teachers are going to, I want you to look at the Schoology assignment for today, or look at the directions. I'm making this video ahead of before I've actually put an assignment into Schoology. So make sure you're looking at your Monday Schoology for your class and see if there's an assignment there. If there is, go ahead and do that assignment. If there's not, then you're done for the day. So I hopefully this lesson was helpful. And hopefully, remember, let's go back to our learning target. Hopefully that we were able to answer this learning target of, coming back here. Miss Bandy says that kids like it when we toggle through. Hopefully it's not too annoying. Do this over here. Hopefully we answered this learning target. I will be able to add and subtract fractions. Do you think you can now? Maybe you already could, but maybe it's just a little less scary now. Hopefully when you see fractions, they make you happy. Fractions equal happy. Okay, we'll see you later, guys. I'm going to log out now. Have a great day. Bye.